Good morning, good afternoon, good evening, everybody. We are happy to invite you and have you on this Waltero Tech Town Hall call. We're gonna present you Mimir dashboard, Waltero application, and Waltero sensor. My name is Kalle Söderholm, and I will be the host today. The Mimir dashboard will be presented by Christian Storm, our CEO and founder, and application and vSensor will be presented by Johan Norden, our Vice President of R&D. But I don't hold you any longer. I give the word to Christian Storm, our CEO and founder. Please, Christian, take the stage and then present our Mimir dashboard.
Thank you so much, Kalle. So I will start by presenting Mimir and where we're at, some new functionality, and also what we are planning to release in the future. So the new version of Mimir is a very powerful dashboard that allows you also to create customizable dashboards out of the box. We also have custom AI pipelines through our Waltero Vision AI functionality that allows you to create custom analysis of the pictures that are being collected by the sensors without having your own data science team involved. We also have introduced enterprise-grade access control, which gives you and your users very granular control over what gets accessed by whom in the platform. And the whole platform is built on an API-first architecture, meaning that integration into your existing system or your SCADA system is seamless and very straightforward. I will start today by mentioning our Vision AI product. And this is based on functionality that is ultra light in terms of the training of machine learning models, and it opens up a lot of new monitoring use cases for you and your customers. Examples of the problems that we solve using Vision AI is high-value remote assets that typically require personnel to visit these sites to do truck rolls and monitor these scenarios. We are now able to monitor these remotely. Examples can be power lines where you'd like to monitor vegetation or ice buildup on power lines. It can be leak detection. It could be monitoring water levels in docks or pipes or filters. Could also be for stormwater monitoring applications to make sure that, for example, these tunnels are clear of debris or other impacts. So what we have shown in case studies together with customers is that we have been able to reduce site visits by roughly 70% for some water utility clients. And this, of course, means enormous cost savings in terms of sending personnel to these remote sites. And what Vision AI means that you can turn every sensor from Waltero into an intelligent observer. And in Mimir, you can create models, you can train, test them, and deploy them very easily with just a couple of clicks. So in Mimir, you define your models, you provide a number of reference images, you provide some assistance in terms of how these images should be interpreted, and then review and deploy them and assign them to your sensors in just a minute or two. We have Mimir Vision available in 3 different tiers. In our basic tier, Mimir Vision, this is meant for basic scenario analysis, all the way up to Mimir Vision Ultra, which is intended for more complex analysis. This could be hairline cracks, infrastructure damage assessments, species identification, etc. And I'll show you a short movie on how this can be used. This is in the case of a customer in Spain, Emacesa, which is using this for stormwater filter monitoring. Let's see if this works.
Sevilla sits atop a vast and complex network of stormwater drains and tunnels. For Emacesa, managing this grid is a constant challenge, as maintenance teams traditionally spend most of their time on routine manual checks, searching for blockages before they ever become critical. But grid management is evolving. Meet Waltero, we are helping MSESA shift from manual searching to precision monitoring. By installing our W sensors at key points across the city, we provide a permanent set of eyes exactly where they are needed most. Deployment is remarkably simple. Our AI platform, MeMir, doesn't need weeks of data or thousands of samples to learn an environment. It is designed for ultra-light training, requiring only a handful of pictures to fully understand the location and begin reporting valuable insights. These results provide a new level of operational transparency. For example, the system can quickly identify when a site requires a follow-up visit or additional attention. This visibility allows teams to coordinate more effectively, ensuring that every task is fully resolved and that no site is left unfinished. It's about closing the loop to guarantee the grid is always in peak condition. This gives MSESA a powerful, centralized way to monitor and control the entire Sevilla grid from a single interface. The city is now better prepared for heavy rainfall, utilizing its resources in a much smarter way. With Waltero and MeMir, Sevilla's infrastructure remains operational, efficient, and fully prepared.
In this brief video, you can see how the pictures from these filters are being analyzed by the MeMir platform and then can be used to decide if there is a follow-up visit required. What we're now adding to MeMir or improving is that our alarms functionality and framework has been transferred from the old version of MeMir, so now have the full alarm support in new MeMir as well. And we are now able to also trigger alarms based on the Vision AI output. And this means that you can create alarms that trigger on classifications, detections, inferred values from the AI pipelines that you set up. It uses the same rules engine as the normal sensor alarms, which are based on battery or meter value, for example. And you can then easily be notified, for example, by email if there is an alarm or if something is going past the threshold that you have defined. We are also extending how you can integrate to MeMir. Of course, we have REST APIs. We're an API-first platform. We're now also adding MQTT access. So within MeMir, you can set up a connector that allows MeMir to push data directly to your platform live as data comes in. And we're now migrating existing customers to this new connector framework in MeMir. In the latest release, we're also improving support for gauges. So this is in the business area of metering, and Johan will show some pictures of gauges in his part of this presentation. But the sensor can interpret gauges such as pressure gauges, and these are not always linear. So it might be that it increases more rapidly in the beginning of the curve and then goes into a linear readouts. And in MeMir, we now have a custom meter type defined that we can create for gauges. We or you can set these up for the customers, where you can basically define what the curve should look like. And this creates support for all types of gauges that are analyzed by our sensors. The MeMir dashboard supports full localization. So we currently have support for these languages that you see on this slide, but we can easily add more languages by request. So if you have a request for additional languages to be added, just let us know and we can add this to MeMir. Finally, a couple of words about integration. So the API documentation is available directly inside of MeMir. Here you can try different API endpoints. You can see the documentation for it directly on the dashboard, and this makes it super easy to integrate with your existing systems. You can also download the full Open API file, which is the complete specification and documentation for our REST APIs for integration by our engineers. And finally, just a couple of words of what will be coming in upcoming releases. We already have applications on MeMir. These are custom applications that defined either by us or by you as partners. These will also be exposing specific APIs that can be used to extract data from Mimir. And we are now adding versioning to this so that you can define different versions of your applications. If customers are on different versions and have integrated to Mimir, you can keep different versions of this deployed depending on the customer organization. We're also adding services within Mimir that will be able to provide a holistic second opinion or analysis of all the data coming into Mimir, both within the metering business area, but also Vision AI, to make sure that all the data that's coming in is accurate. And if there are any deviations, you will be able to automatically flag these deviations using the service. Third point is a full audit trail endpoint for visibility. If any data has been modified in Mimir based on your services that you subscribe to or any other route within Mimir, you will have a full audit trail for all sensors in your platform. So you can see what the original data has been and if there have been any modifications to the data due to the applied filters that you have selected within Mimir. So these are live for all our different environments. These are the addresses for EMEA, for Americas, and APAC. So please go ahead and try it out if you have not already. And just let us know if you have any questions or comments about this. So back to you, Kalle.
Thank you, Christian. Like you see, Mimir is a very powerful tool, and then if there is any questions or you are more interested in to dig in deeper in Mimir platform, please send us the email, and then we go through this. But now we are moving on, and then I give the word to Johan Norden, who goes through the application, Waltero application, and our V sensor. Johan, stage is yours.
Thank you, Kalle. So I'm going to start talking about our installer app that we just recently developed. So the purpose of the app is to make sure that the installation goes correctly. So making sure that the sensor is connected, making sure that it can read the images, read the sensor, and so on. Read the meter, so on, sorry. So we can also do connection surveys in case of, let's say, bad connectivity and so on, and we can do some advanced settings. But I'm going to focus the presentation now on the setup. Basically, you can set up using the cellular networks, LTE, or you can set up using Wi-Fi. So I have a small movie here that will show you the flow when we get the sensor connected. So again, the purpose of this is that knowing that when you've done an install, you know that it's working. You will not have to go back because it is doing what it's supposed to. Yeah, so I'm going to show the image, show the movie here. So this is for the cellular setup. So you first put the sensor in config mode to make sure you can connect to the sensor directly. And you log on to your organization that you want to add the sensor to. So in this case, yeah, I selected the organization and now I'm pairing it to that organization. I do that by scanning the QR code on the side with the phone. And now the app is connecting to the sensor and reading its settings. Now it's testing the cellular connection of the sensor. So making sure that it actually gets connected. And you can also see that on the device, if you look physically, that is flashing. Now it worked, and you can see images from the sensor, and you can play with the brightness here to make sure that it's correct. And once you know it looks okay, you can test the reading of the meter. And now it's running on the sensor, and you see that you're getting the correct result. So you can accept that and go on. And here you can also add some additional information like the external ID, which is like a identifier of the sensor. You can add geographical data, and you can create a picture of how it looked during install, which could be useful when you go back later. So that's basically the whole flow, and that's what you need. So if you go through these steps, you know that it's connected to either Wi-Fi or LTE, and you know that it can take a good image of the meter and read it. So that was that, and that app is available for Android and iOS in the in App Store. So now I'm going to talk to the improvements we've made on the hardware, the sensor itself. So the first and foremost improvement, I should say, is that for those of you who've been working with us before, you know that we had a process before where we were training the meter for each new meter type. So if we had a new meter they haven't seen before, we were starting to collect images from that meter, training a model, deploying that model to the sensor, and then we were able to read. And even though it gave us good accuracy, it took some time from install until data is available to the customer. So therefore, we have created created generic models. So meaning that basically you can install it and it gives you data right away, like you saw in the app example. So, but in order to do that, we created 3 different models. So we have one for analog meters, like the typical old style meter. And then we have one for LCD displays that where the numbers look a bit different and also lighting conditions are a little bit different. We also created an additional model for gauges, like Christian talked about, and I will show you images of that later. So those are, let's say, separate models. We can still train specific models if we, for some reason, find that in this particular meter, we need to be better, or we need to improve this accuracy or that, or whatever, we can still do that. But for most cases, this will do the trick. Right, so these are example of gauges. Here's a pressure gauge and a temperature gauge. So we'll be able to, exactly the same way as we can get numbers out of meters, we can get that out of gauges as well and store that. And as Christian showed, we can also handle non-linear gauges. Sometimes, especially pressure gauges, they can be non-linear in the sense that it moves very quickly in the beginning and then it moves more slowly, and the scale is not linear. So we can adapt to that. Another improvement that we made is that we've improved the onboard processing on the sensor. So again, as you know, all calculations are done on the sensor. So what we see sometimes is, like, for example, here in the example, you see that this needle here is actually indicating 1/10 of a cubic foot. So it's rotating all the time when consumption goes on. And sometimes it's covering the numbers and makes it very difficult to read. So in this case here, it might be difficult to see whether it's an 8 or a 3, for example. But it could also be that we have like a very dirty or worn meter facets, or glare and so on. And what we've done there is, of course, improve the model for reading, but we also added a statistical analysis to the device. So it's now looking into, let's say, the recent readings as well, and combining that to understand what the numbers are. So for example, in this case here, this could be a 3 or an 8, but if, for example, the last 3 or 4 numbers on this position was 8, then most probably it's 8 again, depending on the other, and therefore we can report on numbers that we couldn't report before. We've also improved the power budget, I should say. We're much more conservative in the use of battery. So we've optimized the different components on the main board on the driver level. So we are now really minimizing the energy needed to run the sensors. And another important improvement is that we have looked into the trade-off between connectivity and battery life. So before, if the network went out, we tried really a lot to get connected again. And sometimes that can mean that we use a lot of battery in that searching. So, but what we found is that by doing that, we actually risk losing a lot of batteries if the network is out for a couple of days. But with a new algorithm, it's much more robust, and we will not, when the network comes back, it will connect, but it will not have spent all its battery searching. What we've also done is to improve reading of LCD displays. For different reasons, it's more difficult to take a photo of an LCD display. So as you can see here, as the example here is what the sensor was like in the standard sensor, in the standard mount on on a particular meter. So what we've done is that we made some hardware improvements. We made a light guide insert and some other modifications to the device, and we also created a new mount. And by doing that, as you see, these are pictures of the same meter, and you can see that there's a major difference in readability. So what I want to say with this is that if you're installing on LCD displays, let us know when you place the order so we can make sure that you get the right sensor. I also finally wanted to talk a little bit about Wi-Fi configuration. So as you probably know, the sensor can connect to either the LTE network or Wi-Fi. And sometimes when connecting to Wi-Fi networks, these are private and secure, and it's a little bit risky to allow anyone to connect to that. So what we can do is when you place the order, you can get a list of MAC addresses from us, which is the MAC address of each sensor, which you can then allow list in your networks and make sure that these sensors can connect, but nothing else. We can then also configure the sensors, like setting the SSID password, static IP address, and so on, before we deliver, or you can do that when you get them. You can also use, which some of our customers are doing, they're using hidden SSIDs to make it even more secure. So Wi-Fi, I think, is still a really good option. If you have a Wi-Fi network, it's a robust alternative. It doesn't cost, the data doesn't cost anything, and the bandwidth is good. So I still recommend using it if you have that available. Right, that's all I wanted to say. So back to you, Kalle. Thank you.
Thank you, Johan, and thank you, Christian, as well for the presentation. Like you saw, this was a snapshot what we have today from AI vision point of view, mimir capabilities, as well application and vSensor. And if you have any questions or you look forward to talk about more in detail, please reach out. We are here to help you go through every detail of our ecosystem. So, but right now, I want to thank you, Christian and Johan, your presentations, and all the guests during this webinar. Thank you for participating, and looking forward to see you and make the great business with you together. Thank you.
Thank you, Kalle. Thanks, everyone.
Thank you. Thank you.